Hi, let's discuss about deleting a node at a given position in a circular linked list. Now let us consider a circular linked list with 5 nodes and we want to delete the node at a given position 3. So what will be the input is the list and the position where we have to delete, and this function should return the value in the node in which it is getting deleted. So here we expect the function to return 15. So how it will work is, let us have a temporary pointer, let it point to head, and we also will have a counter and let it be initialized to 1. The concept that we are going to use is, we will place the temporary pointer to one position before the node which is going to be deleted, and then we will be making the changes. So what I try to tell here is, if the position where deletion has to happen is 3, then we will place the temporary pointer at position 2 and then we will be making the changes. So how we can write the algorithm is, while counter is less than position minus 1, we have to move the temp. That's fine. If the position is valid, it is fine. Valid in the sense, I tell like position 3 is fine when there are 5 nodes. Suppose if I give the position as 7, what will happen? If I am just going to follow it, it will come for counter 1, it is here, 2, 3, 4, 5, 6, 7. Again it will come to position number 2. And then we will be performing the deletion, right? We will go up to position number 6, so it will be standing here and we will be deleting the position number 2. Actually, position number 7 is not valid for this case. We have to handle that also. So doing the traversal, we have to check whether we reach the last node. How we can identify that we are reaching the last node in a circular linked list is, if temp next equal to head, then we will understand that we are at the last node. So let us make the while loop to be like, while a position is less than, a position minus 1 is less than counter is less than position minus 1, and temp next is not equal to head. Both the conditions we can check, and the exceptional cases that we have to handle are when the list is empty and when the node to be deleted is at position 1. List is empty means we have to communicate the failure to the callee function, and also we should return minus 1. If the position is 1, then we need to do something more than what we generally do. Like we have to change the head, and if that is the only node, then we have to make your head to null and so on. But already these things we have done in delete beginning. So let us call delete beginning for these two cases and write the code only for the general case. So the formal algorithm may be like this: if the list is empty or position equal to 1, then you will call delete beginning and return the value whichever is returned by delete beginning. Otherwise, let us initialize temp to head and counter to 1. And while your counter is less than position minus 1 and temp is not in the last node, we have to repeat step number 4, where we are going to increment the counter and move temp to the next node. And after coming out of the loop, check if counter is position minus 1. If counter is position minus 1, then we will be doing step number 8 to 11. Otherwise, we have to do these two things. One is, we have to introduce another one temporary pointer, temp1, which will point to the node that is going to be deleted. So the address is in temp next. And you check if temp1 is head, right? This case, when we will encounter this cases, as we discussed, if there are 5 nodes and the node to be deleted is at position number 6, right? Then if the position is given as 6, there is no position 6 at all, right? But the loop condition, what we are checking here, right, while we are not in the last node, we will not have any problem. The 5, it will come to 5 and stand there. So this check will prevent us and protect us from doing a wrong thing, right? So let us check if temp1 is head, and we will communicate failure and return minus 1. Otherwise, we make the necessary changes. Next part of temp will be equal to next part of temp1, and D will be the data part of temp1. Free the memory pointed by temp1 and return D. Let us write the code for doing this. So already we have returned the declaration in header file, which takes the list and the position as the input. And here is the definition in the C file. And I have made few declarations. So temp and temp1 are the pointers we need, and D and counter are the integers we need. And this is the global error flag which we will set if the position is not valid and so on, right? So we have to reset it at the entry. One more thing that we will check here is if position is less than 1, because we are going to give some human kind of interpretation. So we will give like position 1, 2 and so on. If position is 0 or position is -1 and so on, then it is going to be invalid. In that case, we can tell deletion error flag equal to 1 and you can return -1. Okay. Otherwise, in step 1, we are checking if list is empty. How we can check list is empty? Call the isEmpty function with the list, pass it by value, so star s. If this condition is satisfied, once again we have to do deletion error flag equal to 1 and you have to return -1. Okay. And here we are going to otherwise proceed and initialize temp equal to head. When I tell head, I have to refer through the list. So L head, and we'll be telling counter equal to 1, right? Initialize, and while counter is less than position -1 and last node. Okay, first we'll check if we are not in the last node, right? So how we can check? If temp next, okay, if temp next not equal to head, right? If temp next not equal to L head and right counter less than position -1. In these two cases, what we will do? We will increment the counter and we will move to the next node. So let us write it counter plus plus and move to the next node, temp equal to temp next, right? This is done, and in the next step you will be checking if counter equal to position -1. But let us take that later. We will do it before step number 8. Now we will do the other things. So temp 1 will be equal to temp next. We have to do this, and if temp 1 is head, if temp 1 equal to L head, then we have to communicate failure and return -1. So delete error flag equal to 1 and return -1. Done. And make next part of, okay, this is the kind of thing which we should do if position -1 is equal to counter, or we can tell counter equal to position -1. If we are at the right position, then we have to do this, right? Make the next part of temp. Okay, so temp next should be equal to temp 1 next. Okay, and D is going to contain the data, so D is equal to temp1 data. Okay, and free the memory, so let us use free and give the address that is in temp1, return D. Okay, so this is done, and finish the brace. Let us compile the code and check. Okay, there was an extra base which I have removed. Let us now execute the code and check. Let me show the application file. I have got 5 insert end operations. So 1, 2, 3, 4, 5 consecutive nodes or number from 1 to 5. And now I am calling delete at the given position 2. It is working fine. You can see that value deleted is 2 and it is printing the list without 2. Fine. Now let us try giving 6, right? So when we give 6, you can see the deletion failed is printed and it is printing the list with all the 5 elements. I can try giving 7 also. Yeah, once again it is printing deletion failed and list printed is all elements. Let me give something like 0 or negative and check. Once again deletion failed is done, right? Okay, thank you.